This is the fourth in a series of videos on constructing confidence intervals for population proportions. And let's start by looking at another example. So you did a survey and you asked 35 high school math teachers if they liked their mother-in-law or not. I happen to like mine, so that's I was one of the ones that said yes. And you asked these 35 math teachers if they liked it, and 12 said yes. So what you would need to do is construct a 95% confidence interval for p hat, for your estimated proportion. And the first thing you do is straightforward. You just go p hat. P hat is 12 over 35. So you just use your calculator, and you simply go 12 divided by 35 is around 0.343, or 34%. And the next thing you're going to do is you're going to find the standard error of sigma p hat, which is the estimated value, and that's equal to the square root p hat times 1 minus p hat divided by n. And in this case, it's going to be 0.343 times 1 minus 0.343 divided by 35, your sample size. You're going to take the square root of that. So let's do that on your calculator. Now be very careful here. Make sure you do this in a sensible order. The way I do it is I go 0.343 times 1 minus 0.343, and then I hit enter, and then I divide that by the sample size, and then I raise that to the 0.5, which is the same thing as the square root, and I get 0.080. Now from that, we can go ahead and calculate the confidence interval. So we want a 95% confidence interval, and that's going to equal to your point estimate plus or minus your margin of error. And your margin of error is equal to the critical value times the standard error. So let's start plugging numbers in. The point estimate is 0.343. The critical value we're going to look up in a second, times the standard error, which is 0.08. Now let's think about the critical value. The critical value, we're going to choose, we know that it's normally distributed. Since it's normally distributed, what we're going to do is we're going to try to find the critical value for 95%, so that 95% are in the middle of the distribution, which means that we want 5% to be in the two tails, or another way to say that is we want 2.5% to be in this tail and 2.5% to be in this tail. 2.5% is 0.025. And you're going to use your z-table to find this number and find out what critical value. And you could either find the positive or negative critical value, it doesn't matter. If you find the 0.025, that means to the left is going to be 97.5%. So what I'm going to do is I'm going to look on here and I'm going to try to find 0.975. 0.975, or as close as I can. There's 0.98, 977, 976, 975. It actually is right there. It's 1.96. So if this is 1.96, this will be minus 1.96. And then we're done. We just have to multiply. So again, let's plug that in. We have 0.343 plus or minus 1.96.08. Remember your PEMDAS rules, you're going to multiply first. So that's 0.08 times 1.96, 0.157. And now you're going to have to go 0.343 minus 0.157. and 0.343 plus 0.157. .343 minus 0.157, 0.186, and then you go 0.343 plus 0.157, which is 0.5. So your 95% confidence interval will be between 18.6% and 50%. Now that bears commenting. Why is this so large, right? That means that if you're thinking about math teachers and whether they like their mother-in-law, somewhere between half and 19% like their mother-in-laws. Now why is that so large? Well, there's two things. Let's look back to our original problem. The first thing that we notice is that the sample size is quite small, right? You're only asked 35 students, and your confidence interval is quite large. You want to be 95% that your estimated confidence interval contains the true value. So in that case, you would expect, for both of those reasons, that the confidence interval is very wide, and in fact it is. As a last step, let's be very, very careful about what we mean explicitly. So if we say that a 95% confidence interval is, let's do it in percents, 18.6% and 50%, what we mean is that in 95% of the samples, the true P, the true population proportion, will be between, or will be inside of your interval. You have to be very careful here. In fact, P is either in this interval or not. But what we're saying is if we in repeated samples, in 95% of the samples, the true population parameter will be inside your interval. So another way to say that, we say that in English, we say that we're 95% sure that P is between these two numbers. Then we're done.